viewers. In today's session, we are going to discuss another important and conceptual problem from definite integrals. And in this session, we are going to solve this problem in which we are given two functions f of x and g of x such that f of x plus 2 times g of x is equal to e raised to minus x, and the derivative of f of x, that is f prime of x, is equal to f of x with f of 0 is equal to 1, right? So here we are given these three conditions, and we have to find out the value of this integral, that is 0 to 1 square of f of x times g of x dx, right? So let us see how we can find out the value of this definite integral using these three conditions. So let us take this integral as I, right? And here we'll start with these two conditions. So here we are given f prime of x is equal to f of x, right? So we can now solve this equation. This is a differential equation of first degree and first order, right? So here we have a df over a dx is equal to f, right? So here we are writing f of x as f. So f prime of x is equal to f of x can also be written like this. So now separating the variables, here we can write df over f, and here we have dx. So let us integrate both sides. So we can now write integral df over f, and here we have integral dx, and c is the constant of integration. So here the integral 1 over f df is simply a log of f, and here we have x plus c, right? So let us again replace this f by f of x. So we have natural log of f of x is equal to x plus c, right? So now let us use this condition to find out the value of this c, that is constant of integration. So we have f of 0 is equal to 1. So let us take x is equal to 0 in this condition, or in this equation. So we have a natural log of f of 0 is equal to 0 plus c, and f of 0 is 1. So we have log of 1 is equal to c, and log of 1 is 0. So the value of c is equal to 0. So let us substitute this value in this equation. So we have natural log of f of x is equal to x plus 0, that is simply x, right? So now we have natural log of f of x is equal to x. Now taking the exponential of both sides, we have e raised to natural log of f of x is equal to e raised to x, and e raised to natural log of f of x is simply f of x, that is equal to e raised to x. So the function f of x is an exponential function, so f of x is equal to e raised to x. So let us substitute f of x in this equation. So we have e raised to x plus 2 times g of x is equal to e raised to minus x, and 2 times g of x is equal to e raised to minus x minus e raised to x. So g of x is equal to e raised to minus x minus e raised to x over 2, right? So now we have obtained the values of f of x and g of x. So let us substitute these two functions in this integral. So now we can write I is equal to integral from 0 to 1 and square of f of x, that is e raised to x square, and for gx we have e raised to minus x minus e raised to x over 2, and here we have dx. So let us simplify it. We can take half outside the integral. We have 0 to 1 e raised to 2x, and here we have e raised to minus x minus e raised to x dx. So we can now write half 0 to 1, and multiplying these two quantities by e raised to 2x, we have e raised to 2x minus x, then we have e raised to 2x plus x, right? Okay, so now we can write this integral as half, and we have 0 to 1, and e raised to 2x minus x is simply e raised to x, and here we have minus e raised to 2x plus x is e raised to 3x, and here we have dx. So now let us simply find out the value of this integral. So we have I half the integral of e raised to x is simply e raised to x, and the integral of e raised to 3x is e raised to 3x over 3, and the limits of integration are from 0 to 1. So here we have used these two results. The integral of e raised to t dt is equal to e raised to t, and the integral e raised to say m times t dt is equal to e raised to m times t divided by m. So here the value of m is 3, right? Okay, so now we can substitute the limits and we'll take the difference. So first we'll take x is equal to 1. So we have e raised to 1 minus e raised to 3 over 3, and then we have here x is equal to 0. So we have e raised to 0 minus e raised to 0 over 3. So this is half, and we have here e minus e cube over 3 minus here we have e raised to 0 is 1. Here also e raised to 0 is 1. So we have 1 minus 1 over 3, that is 2 over 3. So here we have 2 over 3. So let us simplify this expression. So we have I, and we have half, and 3e minus e cube minus 2 over 3. So we can write I is equal to 3e minus e cube minus 2 divided by 2 times 3 is 6. So this is the required value of this integral I when we are given two functions f of x and g of x, such that f of x plus 2 times g of x is equal to e raised to minus x, and f prime of x is equal to f of x, and f of 0 is equal to 1. So this is how, by making use of these concepts, we can easily solve these kind of problems. Hello viewers, in today's session we are going to discuss an important and conceptual problem from definite integrals. And in this session we are going to discuss this problem where we are given a function f of x which is equal to x times maximum of x square and fractional part of x for all values of x belonging to the interval that is 0 comma 1, where 0 is included, right, and 1 is excluded, and we have to find out the value of this integral that is 1 by 3 to 1 by 2 and fx dx, right? So here the function f of x is given as the product of these two expressions, that is x, which is a polynomial function, and here we have maximum of x square comma fractional part of x. So we have to first modify this function f of x using the expression for maximum of two quantities, say a and b, right? So once we modify the function f of x, then we can easily find out the value of this definite integral, right? So let us start. So now consider two quantities A and B, right? And the maximum out of A and B is given by half, and we have here A plus B plus absolute value of A minus B, right? So whenever we have two quantities, say A and B, then the maximum of A and B is given by this expression, that is half A plus B plus mod of A minus B, right? So here the function f of x has maximum of x square comma a fractional part of x. So a maximum of x square comma a fractional part of x is given by this expression, right? So if we take a is equal to x square and b is equal to a fractional part of x, then the maximum of x square and fractional part of x is given by this expression, substituting the values of a and b. So here we have x square, then we have fractional part of x, and then we have mod of x square minus fractional part of x, right? Okay, now here we have a fractional part of x. So let us utilize the definition of fractional part of x by expressing it in terms of greatest integer function. So fractional part of x is x minus greatest integer of x, right? And here we can see that this function f of x is defined for all values of x belonging to the interval that is 0 comma 1. So we can also write here x is greater than or equal to 0 but less than 1, right? So see, when x lies between 0 and 1 including 0, then the value of greatest integer of x should be equal to 0, right? This is due to the definition of greatest integer function, right? See, if we take x is equal to say half, right, and half belongs to this interval, so half is 0.5, so the greatest integer of 0.5 is equal to 0. And similar is the case with say x is equal to 0, because here 0 is included, so greatest integer of 0 is equal to 0. And similarly, if we take say x is equal to 0.6, then the greatest integer of 0.6 is also equal to 0. So when x belongs to this interval, then the greatest integer of x should be equal to 0. So we can take a 0 over here. So the fractional part of x is now given by x minus 0, that is equal to x. So taking x as a fractional part of x, we have here half and x square plus x plus mod of x square minus x, right? Okay, now our next aim is to simplify this mod function, right? And it is given that x belongs to this interval. So let us make use of the definition of mod function to simplify this expression. Now the mod function is defined as mod of p is positive p whenever p is greater than 0, and mod of p is 0 when p is equal to 0, and mod of p is equal to negative p when p is less than 0, right? So here we have that is mod of x square minus x, and we can write mod of x square minus x as mod of x times x minus 1, right? So let us concentrate on this term, that is x minus 1. Now see, x, it lies between 0 and 1, right? So whenever we have x lying between a 0 and 1, then this expression x minus 1 is always going to be a negative quantity, right? See, whenever we have, say, x is equal to half, then x minus 1 is equal to half minus 1, that is minus half, so which is a negative quantity, right? So when x lies between 0 and 1, including 0, then x minus 1 is always going to be a negative for all x belonging to this interval, right? So this quantity, that is mod of x minus 1, is negative, and x is always a positive quantity, right? So the product x times x minus 1 is always going to be negative, right? So here we have mod of p is equal to negative p whenever p is less than 0. So now using this definition, we can define a mod of x square minus x as equal to a negative x square minus x whenever x square minus x is less than 0, right? Using this definition, because this number, that is x times x minus 1, which is x square minus x, is a negative quantity, and this is less than 0, right? So mod of x square minus x is equal to minus x square, multiplying these two quantities by negative 1, so we have here plus x, right? So now we have half and x square plus x, and here we have minus x square plus x. So x square and minus x square get cancelled, and we have half times x plus x is 2x. So 2 and 2 get cancelled, so we are left with x, right? So the maximum of x square and the fractional part of x is equal to x when x belongs to this interval, right? So now our function f of x can be modified as f of x is equal to x times maximum of x square comma a fractional part of x, and this quantity is equal to x. So here we have x, so we have x times x, that is x square. So using this expression, we have modified this function f of x as x times x, that is f of x is equal to x square for all x belonging to the interval 0 to 1, right? So now we can easily find out the value of this integral. So we have 1 by 3 to half, and f of x dx is equal to 1 over 3 to half, and here we have x square and dx. Now the integral of x square is simply x cube over 3, and here we have 1 by 3 to 1 by 2, right? So taking a 1 by 3 outside, then we have here simply x cube 1 by 3 to 1 over 2, and substituting the limits and taking the difference, we have 1 over 2 cube minus 1 over 3, and here we have cube, right? So the value of this integral is now equal to 1 over 3, and half cube is 1 over 8, and 1 over 3 cube is 1 over 27, and simplifying it, we have 27 minus 8 over 8 times 27, and we can now write here 19, and in the denominator we have 3 times 8 times 27, and this is 19 divided by 648, right? So viewers, the value of this integral is equal to 19 divided by 648. So this is how by using the concept of maximum of a comma b, we can easily modify functions of these kind, and we can further solve these type of integrals.